All right, well, hello. What I'm going to do right now is I want to go over rational numbers again. I started that in class, but I want to continue it a little bit right now. So, rational numbers. Rational numbers. And remember, the definition of a rational number is a number that can be written as a fraction. Okay, so that's what a rational number is. It's a number that can be written as a fraction. So I want to go over a couple of examples right now to make sure everyone's okay with what I am talking about. There are two special rules, so I want to go ahead and give you those special rules right now. So special, oops, I spelled that. Special rule 1. Special rule 1 is the denominator. Denominator cannot be 0. Cannot be 0. Okay, not able to do that. There's a second special rule. I want to give you that one right now. Second one. So we got special rule 2, and that is after dividing fraction, the decimal has to end or repeat a pattern. Okay, so we got our definitions here, and we have our two special rules. So I'm going to go ahead and now begin on going over some examples. Okay, let's go over some examples of rational numbers, and let's determine if they are rational. So the very first number I want to talk about is the number, let's go 5. Okay, can we write 5 as a rational number? Now remember, a rational number is going to be an over b, which is going to be your numerator and your denominator. And remember, the denominator cannot be 0. So can I take 5 and can I make that into a fraction form? Well, of course you can. You could do 5 over 1, or you could do, 20 over 4. Those are just a couple of examples that you could. So 5 is a rational number. How about, a decimal? How about 0.45 or 45 hundredths? Is this rational? Well, remember the definition is, can you take your number and can you write it as a fraction? Can you take 0.45 and write it as a fraction? Well, yes, you can. You can take this and you write 45, and then you tell me the place value of the last digit. So that is going to be 100. 45 over 100. Of course, I could simplify that by dividing both numerator and denominator by 5, and I get 9/20. So this also is a rational number, just like number 5. There's two examples. Let's take another one. Let's go with -3 2/5. -3 2/5. Can I take this mixed number and write it as a fraction? Well, you sure can, because to take a fraction and turn it into a mixed number, you do denominator times whole number, so 5 times 3. Add the numerator, so that is going to be 5 times 3, which is 15, plus 2 is 17. That is 17 over 5, and it's negative. This is rational because the numerator is, or denominator is not 1, so that does work. Let's do another example. How about good old 1/2? This is also a rational number because there is not a 1 in the denominator, and when you do divide according to special rule number 2, it ends. So 1 divided by 2, top dog in the house, 2 goes into 1 0 times, but 2 goes into 10 5. If you notice right here, the 5 ends, it stops. Okay, 0 there. So this also is a rational number according to special rule number 2. If I go back up here to special rule number 2 and test this out, when I take 3 2/5 or 17 over 5, I'll have my 3, but now I need to divide 2/5. So I do top dog in the house. I'm going to do 2 divided by 5. 5 goes into 2 0 times. 5 goes into 24 times. So the answer is 3.4. And that is rational because it does end. Let's do one more. Okay, here's going to be the last example that we do. Let's go with 3 over 7. 3 over 7. So what we're going to do is I'm going to do top dog in the house. I'm going to do 3 divided by 7. Seven goes into 3 0 times. 7 goes into 30. I'll bring this decimal straight up. 7 goes into 34 times. 28. 2. Bring down your 0. 7 goes into 20. 2 times. 14. 6 is your difference. 0. 7 goes into 60. 8 times. 56. Subtract 4. Bring down your 0. 7 goes into 40. 5 times. 35. Subtract. Bring down your 0. 7 goes into 57 times. 49. Subtract 1. Bring down your 0. 7 goes into 10 one time. 7 times 1 is 7. Subtract 3. Bring down your 0. If you notice here, it's going to start to repeat. 7 goes into 34 times. 28. You have 2 left over. And if you notice, you'd bring down a 0 and it starts to do the same thing. So 3 over 7 is equal to 0.428571, and I'm going to use what's called the bar notation because this repeats. Technically it goes 0.428571, 428571, and then it just keeps going on and on. So instead of writing this, I do what is called bar notation. Okay, so according to special rule 2, it says that after dividing the fraction, the decimal has to end or have a repeating pattern. This has a repeating pattern. Therefore, 3/7 is rational. Okay? It's a rational number. Now, let's give you a number that's not rational. Okay? Here is a number that is not rational. For example, pi. pi, when you divide it, the number continues to go on and on and on forever. Pi written as a fraction, you could write it as 22 over 7, but it's 3.14, and then it just continues to go. And there has not been a repeating pattern. So pi is actually irrational. Okay? Irrational because it does not follow these rules here. Okay? This right here. So I hope that does help.